What truly makes the moon have such a wide range of faces? While our steady buddy is known to us as usual, presenting only one in the same side, its secret opposite side has been accompanied by audacious hypotheses and theories since days of yore. However, now, excitingly, scientists might have made an unequivocal forward leap in addressing the tempting moon secret. In light of the fact that, as we now know, the South Pole Aitken Basin conceals an astonishing secret underground. According to this, a giant structure sleeps on the invisible side of the satellite, which, on one hand, gives a deep insight into the tempestuous past of the heavenly body, and on the other, could make sense of why the two parts of the moon contrast so decisively from one another. What today takes only a couple of clicks of the mouse was an inexplicable problem for millions of years. While we are now in the comfortable position of being able to wonder about the farthest side of the moon from the comfort of our living room couch, our predecessors essentially had absolutely no chance of getting a brief look at the clouded side of our devoted buddy. This is just because the moon has a bound rotation, and consequently, it always turns the same side towards us. Exhaustively, anyway, the divine body was not always so bashful about its side. In fact, after its formation, the satellite might have rotated a lot faster before it was dialed down so much by the Earth's gravitational pull over time that its rotational speed matched its orbital speed. However, since observers from this far-off lunar time are in short supply, humankind had to wait until October 7, 1959, before the Soviet spacecraft Luna 3 revealed the secretive far side of the moon for the first time in history. 60 years later, Chang'e 4 was the first space probe to land on the clouded side of the moon. Even though, strictly speaking, it's not as dark as it is often said, the side of the moon facing away from the Earth goes through the very same lunar phases as the side that shines towards us overhead every night, just in the opposite sequence. In fact, the far side of the moon has a higher reflectivity on average than the near side, which only means that the hidden region shines brighter at new moon than the visible side at full moon. This is due to the different compositions of the two parts of the moon. Although the word parts isn't exactly right in this context because of the moon's orbit being shifted at 5 degrees and its spherical shape, only 41% of the moon's surface is visible from Earth. But those 41% are enough to see that the front side of our satellite is decorated with dark spots that are as broad as they are endless. These are, therefore, the so-called maria, seas, swamps covered with solidified magma, and these structures are much rarer on the opposite side. At the same time, the far side of the moon also has significantly fewer lunar mountains. For years, scientists have been trying to make quick work of the explanations for these confounding contrasts. But now, and this is the exciting part, specialists believe they have finally solved the secret of the different lunar sides of the equator, and the justification for it lies latent in a hidden giant structure far beneath the lunar surface. The giant construction on the far side of the moon is, for many, the ultimate travel destination. No surprise, since the enormous main island, which covers over 10,400 square kilometers, not only boasts unique black sand beaches but also one of the largest active volcanoes on Earth, Mauna Loa. But what does a paradisiacal getaway island in the Pacific have to do with an extraordinary discovery on the far side of the moon? Well, the answer is astonishing. Peter B. James of Baylor College in Texas summarizes it as follows. Imagine a pile of metal multiple times bigger than the main island of Hawaii and cover it underground. That's essentially the unforeseen mass we found. The keyword heap of metal could lead some to think of a massive spaceship that once crashed into the outer layer of the moon, but it's not exactly like that. To figure out what the unforeseen mass is truly about, we first need to imagine its location. It isn't just any location. It's the South Pole Aitken Basin, and thus the largest preserved impact crater in the entire solar system. There is no doubt that this, with an incredible degree of something else than 2,000 kilometers, still takes the stand regarding a brutal grandiose accident. Today, what is much more problematic, however, is how exactly the fierce impact happened in the estimated 4.3 billion years ago, and what impacts it had on the further development of the then still young moon. To get closer to solving this intriguing secret and to explore the nature of the subsurface at the south pole of the moon, in the same breath, Peter James' team examined data from the Gravity Recovery and Interior Laboratory (GRAIL) mission in September 2011. 2 space probes had set out for the moon to study its gravitational field and irregularities and to provide valuable new insights into the interior structure of our satellite. The baseline is that the specialists combined the GRAIL data with those of the Lunar Reconnaissance Orbiter (LRO), which has been in operation since 2009 to map the entire lunar surface in high resolution. As mentioned, James' research group eventually identified a massive mass anomaly far beneath the South Pole Aitken Basin. To make sure we're all on the same page, we're talking about a structure that reaches a depth of 200 kilometers and weighs an incredible 2.8 times 10 to the power of 18 quadrillion tons. For comparison, The mass of the entire Earth's atmosphere is estimated at around 5.15 quadrillion tons. But what on earth is hidden in the invisible universe of the moon's surface? Well, that likely depends on who you ask. While the more alternative minds believe it's possible that we are actually dealing with a secret base of an unknown lunar civilization, the more moderate scientists take a more conventional approach. More specifically, this refers to the metallic core of the asteroid that made the giant impact basin in the distant past. This is by no means an obscure approach, but rather the result of a programmatic experiment that showed that such an iron-nickel core could penetrate deep into the moon's upper mantle during an impact without necessarily sinking into the center of the heavenly body. In this context, the sheer weight of the asteroid's core could also pull the bottom of the crater nearly a kilometer deeper into the ground. So, possible. But it should be noted that researchers are also considering a second hypothesis here. This one relies less on an asteroid core and more on a huge clustered aggregation of dense oxides that once formed at the moon's south pole as the primordial magma sea cooled and solidified. Have we solved the secret of the moon's sides of the equator? Future research will show which hypothesis is ultimately correct. However, if we are dealing with the artifact of an impact, it could also help us understand the puzzling differences between the sides of the moon. In addition to the unevenly distributed maria, we now also know that the crust on the near side of the moon is significantly thinner than that on the far side. At the same time, we also find a crust on the Earth-facing side that is enriched with curiously high proportions of radioactive thorium, potassium, phosphorus, and other interesting Earth components. But how this so-called wet blanket landscape came about is just as unclear as the question of what set the lunar volcanism in motion. Some scientists estimate that the differences in the moon's crust can be traced back to the flowing forces of the Earth. Others view a catastrophic impact as the most promising explanation. One of them is Matt Jones from Brown University in Rhode Island, who, together with his colleagues, studied the effect of the massive heat from the impact at the moon's south pole on the entire heavenly body. Strangely, the South Pole Aitken Basin is exactly opposite the area known as the serene landscape, so perhaps we are dealing here with an event that isn't really a coincidence at all. The resulting simulation of the impact was based on geophysical models of the early lunar interior, and it eventually revealed something striking. Yes, the impact could indeed have triggered a thermal anomaly in the lunar mantle, which significantly affected the development of the moon's interior over millions of years. The impact with the asteroid, which was around 100 kilometers in size, led to an enormous heat flood that spread through the moon's interior to the opposite side. In doing so, it also affected the area that is now known for its various maria and basalts. This process ensured that titanium-rich magma aggregates were moved to the side facing Earth, much like how a surfer is carried along by a wave. According to the simulation, the heat generated and the subsequent mantle convection were sufficient to explain both the unusual dry development and the basalt-rich rocks of the maria. Furthermore, the impact at the moon's south pole may have even triggered volcanism and the subsequent formation of the maria. In any case, the event likely thought to create heat-producing elements on the near side of the moon. This combination of radioactive heating and increased mantle convection might have literally energized the upper mantle of the near side over millions of years. Thus, the hot magma was able to enter to the surface in tremendous emissions. As indicated by specialists, the first emissions happened around 200 million years after the asteroid impact. However, the most extreme period of the lunar volcanism didn't follow until 300 to 500 million years later. The main concern is that the South Pole Aitken Basin and the nature of the moon's front side are obviously directly associated, and that one of the best lunar secrets of all time may finally be a thing of the past. We hope that, in no time, tapping on the subscribe button will also finally be a relic of the past. Become part of our community now and never miss another video from us in the future. We'll see you soon.